We have already covered the fundamental concept that we have in SQL, and in this lesson we are going to cover some of the advanced concepts. So the first thing we are going to look at today is the auto increment feature available in SQL. This auto increment allows a unique number to be generated automatically when a new record is inserted into a table. So most of the time, we will see that this is the primary key field that we want to have a unique ID for each record. So this is how we can define an auto increment primary key column. In the normal create table query, we can specify next to the column name auto increment. So this is a special keyword that we have, and the rest of the table is a normal create table query. So when we execute this SQL query, we will get this kind of a table. We have a ID, name, and age column, and ID is going to be the primary key. And also, since we use this auto increment keyword here, this ID column will now be an auto increment column. So let's see by inserting few records into this table what will happen. So as you can see here, we are inserting into the persons table and we are only providing the name and age values. So we have put Ellen as the name, 22 as the age, and we haven't specified a value for ID. But when SQL insert this record, it will auto generate an ID for this column. So the first ID would be 1. And we execute another insert query. So again, we are providing two values, the name and age, body 23. And that means another record will be inserted here. And again, the ID field or the value for the ID column will be automatically generated. And that will be number 2. And the next time it will be number 3. So that is what we mean by auto increment column. The value is automatically generated incrementally. And the next thing is we are going to cover how we can use date and time in SQL. And SQL support these 3 different types of date and time formats. First, we can use the date type for a column. And when we say a column is in date type, that is the format would be this. So this is how we usually represent a date format by 4 Ys, 2 Ms, and 2 Ds. That means the year, dash month, and another dash, and the date. So this is one. There are multiple different ways how we can represent it. Using maybe the date first, month second, and the year for third. Oh, there are various different ways. But in SQL, when we say a date column, this is the format that it will store. And we can also have a date time column where the format would be the same as the date. And additionally, there will be a time segment where the hour followed by the minutes and seconds. And there's a third format as well, which is a timestamp, which also has the same date time format similar to this one. And different database system have different formats for date time data, but this is the most common format used by most of the SQL databases. But you might find that some SQL implementations might have a slightly different format. So these are the date and time related data types. And additionally, there are many different date related functions as well to accomplish various different functionalities. And let's see how we can have a date column. So in this example table, we have a column order ID, product name, and an order date. So as you can see, this order date column is of the type date, since it represents a date value. And as you can see, this is the format that we said the date column will store values: year, month, date. And if you want to find all the orders that was placed on a particular date, we can simply write a where clause where order date equals this particular date. And again, we have to remember that we provide the date for the where condition in the exact format. So when we execute this query, we should get this as the result: the two order records which were placed on this particular date. Now let's look at some of the date related functions. And again, these functions differ from SQL database system to system. So what I have taken here are few date functions available in MySQL. So we know MySQL is one implementation of SQL standard, and there are various other different types of databases as well. So I have taken few functions available in MySQL here for examples. And one of the first functions is the now function. So as you can see here, now, and since it's a function, we have these brackets. So that basically returns the current date and time. So if you simply write an SQL query select now, that will give you a result set where you get the current date and time. So as you can see, since it's a date and date time, this will be the format: year, month, date, and hours in 24-hour format, minutes and seconds. And there's another function called add date, which adds a time or a date interval to a date value and then returns the calculated date. For example, if you want to add 10 days for a particular date value, you can use this add date function. Add date, the first parameter should be the initial date. Then you can provide this interval keyword, interval, and how many days or hours here as a number, followed by whether it's a day or hour or minutes or years. So if you say interval 10 day, this add date function is going to add 10 days to this date, June 15, 2019. So we will get the result as June 25th, 2019. So if you say interval 10 month, that should add 10 months to this particular date. Or if you want, you can say some number of year, say 2 year, and it will give you 2021 6/15. So similarly, you can add any number of date, month, or even year as an interval. And similar to add date, there's another method, subdate, which subtract a time or date interval from a given date and then returns the date. So it is very similar to add date. Only thing is, instead of adding this particular value, it will subtract it. So when you say subdate June 15th interval 10 day, it will actually subtract 10 days from this. So we will get June 5th as the result. And there are various other different functions similar to this available in SQL. You can simply refer the internet. If you type MySQL date function, there will be a list of all the different functions available with the documentation and examples. Then we will move on to another different data type that we have in SQL, that is large object type. Sometimes we may have occasions where we want to store large amount of data, like maybe photos, videos, or some certain files in the database. So what we have seen so far is basically numbers and strings. So to represent this kind of large data items, SQL has this data type binary large object, and they will be stored as what we call a blob. So blob is basically a short format for binary large object, BLOB, binary large object. So an object is basically a large collection of uninterpreted binary data. So what we mean by uninterpreted is who the interpretation of the data is left to an application outside of the database system. So if we store an image as a blob or a binary large object, the database is not going to be concerned about the actual representation of this data, whether it's an image or whether it's an application or whether it's a Word file. It doesn't matter for the database. All it knows is that it's a binary file, and it doesn't know how to read that or interpret it. So that is left to whatever the application that this data will be used by. And MySQL database particularly supports 4 different blob types. Tiny blob, which can store up to 256 bytes. So if you have maybe a small amount of binary data, maybe a small image, you can use a tiny blob. Or if you have a little bit more amount of data, you can use a blob. And if it is even larger, you can use a medium blob. Or if it is very large, you can use even a long blob data type, which usually supports up to 4 gigabytes of data. So even a large video file can be stored as a long blob. Then we will discuss about aliases, a new concept that we are going to learn in SQL. So as the name suggests, aliases are used to give a table or a column a temporary name. And we often use these aliases to make column names or table names more readable and shorter. So this is how we can use an alias. So we write select column name, so the usual select query. And this is the part we define an alias. We say select column as alias name. So here we have to provide a different name or alias that we are going to identify this column as, and then followed by the from table name. So let's check this example here. So we have a table with 3 columns: store name, sales, and tx end date. So as you can see, the column names are a bit long in this table. So we can use alias to shorten that and get some small and meaningful names. So here we have written an SQL query, select store name as name. So we have given an alias name instead of the column name store name. Then sales and txn date as date. So here we have defined another alias for this particular column and from stores. So let's say the table name is going to be stores. And when we run this query, we will get the result set as this. The store name column will be now named as name, and sales column we get directly, and the txn date column will be now named date. So this is the result set that we get. It doesn't change anything in the original table. It remains as it is. We only get the result set with the alias names. Let's see a different example where we can actually have an alias for table names. So let's take this example of where we want to join the customer table onto the orders table using the customer's ID. So we would have normally written it as select orders.order_name and customer.name from orders, left join customer on customer ID equals orders.customer ID. Since it tends to be a long query, we can actually shorten that by using aliases. So here what we have done is we have provided an alias for the orders table as O, and we have another alias for the customer table as C. And now we can use this alias instead of the original name orders and customer. So that is why we have written it as select order_num c.name, and even here as c.id equals o.customer ID. So what we mean is when we say o.customer ID, that means the orders.customer ID. So by using an alias for both of these tables, we have managed to reduce the length of the query. So when we want to write complex queries where we might have to join couple of tables and maybe have nested queries, it might be a good idea to have aliases since it makes the query more readable and shorter. Next, we will look at how we can order the result sets that we get from select queries. For that, we have a special command or a keyword in SQL, that is order by. And using this order by command, we can sort the result set either using in ascending order or descending order. So this is how we can write the order by query. So we have a normal select query, select columns, whatever the columns from the desired table, followed by this new keyword order by, and we can specify using which column we want to sort the result. So that can be one or more columns. And followed by, to indicate whether it's ascending or descending order, we have to specify ASC or DESC. So when we say ascending, we have to specify the ASC, and when we want it descending order, we have to specify DESC here. So let's check for an example. So here we have the same table where we have the store name, sales, and the TXN date columns. And we have written a select query, select all from stores, order by, sales, descending. So that means we want to select all from this table and we want to sort the result set using the sales column in the descending order. So that means the largest one to smallest one that should be sorted. So we will get the result as this. You can see now the largest one is on the top, second largest is next, and third largest and the smallest is the final one. So if you want, you can even specify multiple columns. In that case, if there are two identical values, the second column will be used to sort the tiebreakers. And there's another function or a command that goes related with this order by command, that is limiting the result set. And for that, we have a keyword limit that restrict the number of results returned by the SQL statement. For example, if we want to get only 5 results, we can say select columns from table name, limit 5 here. Then the SQL will only return 5 records matching this whatever the select criteria. And usually we will use it with the order by clause. So again, let's take the same example table and let's try to retrieve the two highest sales records. So again, we have the same select query, select all from stores, order by sales, descending. So that means from largest to smallest. And we want to limit the number of rows in the result set to 2. So that means it will first select everything from this table, sort it using the descending order, and it will return the topmost 2 orders. So the topmost one will be the largest sales value 1500, this record, and the second one will be this record, and the third and fourth records are not returned because we have limited the result set to 2. So if you wanted to have the highest sales amount or the record with the highest sales, we can simply change this to 1, then we will only get this record. Similar to tables, this SQL has another concept of a virtual table, and that is known as views. A virtual table or a view is constructed from other tables, and the result set is based on an SQL statement. So just like a table, views also contains rows and columns, and we can simply define a new view using create view statement. So this is how we can define a view, create view, and we have to provide a name for the view as followed by any SQL select query. So let's see an example to clarify this. So here we have written a create view statement, and let's assume there is a table called customers, and it has a column country to indicate each customer's country. And here we are going to write create view, and we have named the view as Brazil customers as followed by a select query, and select query says select customer name, contact name from customers where country equals Brazil. So if we forget this part, this is a normal select query which will select all the customers where the country is Brazil. So what we have done using this create view command is this result set is now being created as a virtual table or a view, and it has a name Brazil customers. And then later we can use this new view Brazil customers just like another table. So if we want, we can query this table like select all from Brazil customers. So we no longer have to write this particular SQL query again to select all customers from Brazil because we have already have it as a virtual table or a view. So it will behave mostly like a table. If you use a GUI client application, you can browse the table just like a normal table, and it will show all the columns available and the records available. So why we want to use views is a view hides the complexity of a database table from the end user. So we might have to write a complex SQL select query to get certain information. And if we define it as a view with a particular name, we only have to do it once. And maybe a less experienced user with SQL doesn't have to bother about the complexity of writing that SQL query again and again, he can simply take a look at the view as a table. So we hide the complexity of that select query from that particular user. And also it has another advantage where maybe sometimes we can hide certain data from the view of certain users. And as an example, let's say there's a user who needs to know about an employee's name and department, but we don't want to disclose the employee's salary amounts for this particular user, since it is considered as a sensitive information. So instead of giving access to the original employees table, we can create a virtual table or a view by selecting only the employee name and his department and exclude salary from the select query and name it as a different view. So we provide access to this particular view for the user and he can only see those two columns. So as I said, unlike tables, a view does not store data. It's a virtual table where the result is computed dynamically when we access the view. So if anything changes in the original table, that will be represented in the view as well. And it is also possible to use insert, update and delete queries on the view, since it behaves more or less like an actual table. But these operation where the values get updated is only possible when we do not have any aggregate functions or joins or group by operators in the select query for the create view query. So if we do not use any aggregate functions or joins or group bys, you can see that there's a direct one-to-one mapping between the records in the original table and the records in the virtual table or the view. So that means we can, or the SQL database is able to update any record in the view by updating the original table. But if we use aggregate functions, like maybe the sum or medium or even use joins, there's no one-to-one connection in between the records in the virtual table and the original table. So the database is now unable to figure out which records should be updated in the original table when we write a insert, update or a delete query. So that's why it is not possible. And the last concept, nested subqueries. SQL provides a mechanism for nesting subqueries in any other SQL query. And what we mean by a subquery is a select from expression that is nested within another query. And most of the time, a common use case of these subqueries is to perform a test for a set membership. What we mean by set membership is if we wanted to check whether a particular record is belongs to a set of other records. And let's consider this example. We have a select all from customers query where cust id in and within brackets we have another select query. So this part is called a nested subquery and it must appear within parentheses, these brackets. And for a moment, let's just forget about this and only consider this select query where it says select distinct customer IDs from orders where the amount is greater than 5,000. So this will select all the order records which have an order amount greater than 5,000. And since it says distinct customer ID, it will only select the customer ID column from the orders table. And again, distinct means only the set of unique customer IDs will be selected. And now if we go back for the wrapping SQL query that says select all from customers, where customer ID is in the set of customer IDs selected by the subquery. So this keyword in check whether the customer ID is in this set of values. So we are basically selecting all the customer information who has ordered or who has made an order greater than 5,000 in amount.